Welcome to Level 1 of Simplifying Rationals homework. Level 1 consists of monomials being divided by monomials. The first question you might have is, how can I tell if it's a monomial? If we look here in our numerator and here in our denominator, I can tell that both of those are a string of numbers and variables that are being all multiplied together with no pluses or minuses between them. That makes them monomials. Once you start adding pluses and minuses, it makes them binomials, trinomials, or even polynomials. The first thing that I want to do to get started to simplify, I'm going to draw a fraction bar here for our solution, and then one down here so you guys can see the work as we start to simplify. The first thing that I want to do is always look at your coefficients. Coefficients, the numbers in front, get simplified just like a regular fraction. So I want to think, what is the biggest number that can go into 24 and 64? If the biggest number doesn't jump out to you at first, which would be 8 in this case, say maybe you thought 4, you would go, okay, 24 divided by 4, or goes into 4, not 4 times, but, 6 times, and 64 divided by 4 is 16. So you're very confident, you go, okay, my answer is 6/16. But then you look at it a second longer and you check over and you go, 2 can also go into both of those, so I need to keep dividing or simplifying. 2 goes into 6 3 times, and 2 goes into 16 8 times. Now, I know if my fraction or my coefficients are simplified if the largest number that goes into both of those is 1. Nothing else but 1 goes into 3 and 8. So that is our simplified coefficients. The next thing we want to look at is our a variables. If simplifying with exponent properties makes more sense to you, a squared over a would be a2 minus 1. 2 minus 1 would give you a1, and it was minus 1 because there's 1 in the denominator. Or if the expanded method makes more sense to you, which I'm going to show you here, all of this would be multiplied. I have a squared in my numerator, and I have only one a in my denominator. Now, because I'm multiplying, all of this can be simplified. If I start having more factors or adding pluses and minuses, it gets a little bit more difficult, but not too much. Nothing you can't handle. So I can cancel one a in the numerator with one a in the denominator. So I can do those two, or you can do those two. It doesn't matter which one you prefer or do, so long as you have one in the top with one in the bottom. So we're left with 1a in my numerator. Now we can look at our b's. We'll do that in green. So again, if your exponent properties make more sense to you, b3 over b5, or to the third power and to the fifth power. So that would be b to the 3 minus 5. And that would give you a negative 2. I'll write that off to the side here. Would give you b to the 3 minus 5. So b negative 2. But remember, we don't like negative exponents, so that would be 1 over b to the positive 2. It flips over the fraction bar. And if you prefer the expanded method, you'll see how we get the same thing. And again, all of these are being multiplied, and that's why we can simplify this way. And one more. Extend that out a little bit. Okay. Same thing we did with the a's. I can do 1b in the numerator with 1b in the denominator. You could get a little crazy and do kind of random ones, but I would suggest keeping it organized and doing the first three with the first three. That way you'll be able to more clearly see your solution. And I see I have two b's in my denominator, which was the same thing that I got over here with the exponent properties method. Either way works. Two b's means it would be b squared. And if we want to write our solution a little bit nicer, hopefully, 3a all over 8b squared is our final solution. Now, you do want to be careful and make sure that you always review your work and make sure your final solution doesn't have anything else that you need to reduce, either with your coefficients, like with the 6 and 16, or with your variables. In this case, everything is reduced and simplified, so I'm good to go.